Silwani. That is MP. M means Majani Filimo. I'm going to do the following with you. The first one, let us just stick with the first one. It will be areas. And I think it was somewhere, I'm not sure which unit. Somewhere it says unit 10, somewhere it says unit 9, but it doesn't matter. As long as we all agree or we are all aware that today's session, today's lesson, it will be about the area. And please, dear students and everybody, this session is yours. It's not mine. It's ours. So feel free. Stop us at any time. You can just simply raise your hand. If I can't see your hand, just jump in, shout, so that we can help you. Now, what I've asked you to revise, it was just basically very simple. Number one is what? The area of standard figures as covered in your secondary schools. I mean, standard figures like triangles, rectangles, circles, and whatever. That is number one. Number two, surely we will need what? Because this is under the application of integration. Therefore, you need to revise, which I think you did. That is basic integral rules. Although some of them, they go beyond basic integral rules because they will use what? They will need you to know, integration by parts, all those techniques of integration, the trigonometric substitution, the whatever, all those integral techniques that you went through with Mr. Gone. And obviously, you will need also what the formula sheet as well as your calculator. If you have done that, then everything should be very, very smooth. Now, let us get started then. Now, we all have an idea of what an area is. I mean, if you have revised those, the area of standard geometrical figures, like what? The area of a rectangle, the area of a triangle, so on and so forth. Then, therefore, let us get started. Say you have this. Let us assume it's a rectangle. That is, this is perpendicular to this. Therefore, clearly, it's a rectangle. Now, we don't have to name this. Let us say from here to here, for argument's sake, is 4 units, 4 centimeters, 4 kilometers, whatever. And say this side is 3. And now the question is, find the area of this rectangle. What will be the answer? What is the area of this 12. Rectangle? It's 12. What is important is, that's good. What is important is, how did you arrive at that correct answer, 12? Because definitely 12 is the only correct answer. It may not be the only answer, but that is the only correct answer. Anything other than 12, it will be 0. How did we arrive at the 12? Because it's standard. Therefore, it has a formula. And what is that formula? It will be A equal to multiplied by B. It's a rectangle. There's a formula for that. Just like a rectangle, no? Just like a triangle, there's a formula for that. For the area of a triangle, there's a formula for the area of a circle. So now here, it is just to plug in. What is L? Obviously, L will be the distance from here to here, which here we have said is 4. Therefore, it will be 4 multiply by what is B, it will be this distance, which we know is the same as this distance because it's a rectangle. It has got a right angle triangle here. You can just use another one here. Then it will be 3. Then the answer will be 12 square units. It will depend on the measuring units here. Maybe 12 centimeters squared or 12 kilometers squared, 12 meters squared, whatever. It's good. But now here, the question is, what if this is not a rectangle, a nice rectangle like this? But now, before we even go there, now, this side, let's say this side it is. We are going to say is the top function, or it's just part of the top function, or it's a piece, because here, this one, enclosed, this is the region. Let us shade it. This is the region. Then the question was, find the area of this shaded region. And the region here is a rectangle. Now, this is like a fence, or it's like a top fence. Is the one that encloses this region on top. This. It encloses this region on top. And this one, enclose our region at the bottom. Or it's like the fence of, it's like the bottom fence or the bottom wall. It will depend. So this is the top fence or the top boundary or whatever, or the top function of this region. And this one here is like what we call the bottom. But now, in our unit, now this is going to be extended. This one, it's not just going to be from here to here. It will be extended like this. And because it's a horizontal line, it's horizontal. Therefore, it will be given by y equal to something. The same thing with this. Generally, it will be given by, because it's a horizontal line, it will be given by, let's say this is y1. And this one will be given by whatever, maybe y2 equal to 6. We don't know. The same thing with this one. Is forming the left boundary of our region, the left boundary. And because it's a vertical line, therefore it will be given by the line x equal to 3, x equal to 4, or whatever. The same thing with this one. It will form what? If you look at this region, it will be like our right boundary, or our right wall, or our right fence. This region is enclosed by 4 functions. If you can look at this, it's enclosed by 4 functions. One on top, the other one at the bottom, another one on the left side, which is x equal to something, another one on the right side, which is x equal to something. It will depend. So now, if you take this region and plug it on the x Cartesian plane, if you plug this on the Cartesian plane, then from there, then this will be the x-axis. We know it. It will be the x-axis, and this is the y-axis. And this, it doesn't change the value of the area of this. It's still a rectangle. And then from there, they say now, find the area of this shaded region. Find the area. This is a region. This is the region. And the question will be, find the area of the region. This region now. What will be the boundaries now? or what is the fence of this region? It's enclosed by which curves or which functions? It's enclosed by which functions? Anybody? This part is part of which function? This part from here to here is part of which function? This part from here to here is part of which function? This part from here to here is part of which function? In other words, this is enclosed by definitely 4 curves or 4 functions or whatever. So, anybody name any? Then it
I
will
think
be
the
Y1
is the upper bound. The one that goes
how much now here? Which is how much?
The one Y1.
Let us. Yes. What is Y1?
I think it's 4. If it's the same height, same length.
I don't agree with you. What is Y1? Remember, 3 is from here to here. Yes. 4 is from here to here. 4 is from here to here, which is the same as from here to here. 3 is from here to here, which is the same as from here to here, which is the same as any vertical line that join the bottom boundary and the top boundary. 3 means from here to here.
So Y1 doesn't have a bound.
If from here to here is 3, then what is the equation of this line, horizontal line? If from here to here is 3.
Oh, Y is equals to 3.
Then it will be Y equal to 3. That is Y equal to 3. Y equal to 3 is one of the fence. You see. Therefore, Y equal to 3 is going to form our top function. It's going to form our top boundary. It's like it's going to form our top wall. And any other boundary here that is enclosing our region. This region is enclosed by 2. No, not by 2, by 4. One of them is Y equal to 3. That is this, Y equal to 3. Another one is what?
X.
Anybody?
Y to 4.
Y?
Y equals to 0.
Y equal to 0. That is the x-axis. Don't forget. This is the x-axis. That is Y equal to 0. Meaning you can say it's enclosed, but you can say find the area of the region and of the region enclosed by say here enclosed or bounded by Y equal to 3. That is this one. And what? That is the x-axis. The x-axis, which you can say Y equal to 0. Remember, you can say the x-axis or Y equal to 0, meaning this one. And what?
X is equals to 4.
X equals to 4.
X equal to 4 is this one. That is X equal to 4. Is that all?
And X is equals to 0.
And X equal to 0. And X equal to 0. Don't forget X equal to 0. You can say what? The y-axis. X equal to 0. You can just say the y-axis. You can just say here the y-axis. So you can see this. These 4 are our, they form our 4 boundaries. Now, hopefully we are together. Once you can understand this, then we can throw any area question now. You will be able to answer any question related to the area, as long as you will be able to identify your functions that are forming the boundaries. That's all. That is the starting point. Then what will be the area now? What is the area of this region? Using integral method or approach, the area here, it will be A, it will be, then you say the integral. Now the integral of what now? It will now depend now. It will now depend. It will now depend. Please make sure that you are with us now. It will now depend. Now, if, for argument's sake, or we have already talked about this, to say what? This region, it doesn't matter where you are, it doesn't matter where you stand in this region. Whether you are here or here or here or here or here, if you look up, or you try to go out of this region, you will be prevented by this top fence. If you are here, then you want to go out of this, you will be stopped by the top function. You can't be stopped by the bottom function. You can't be stopped by this one. You can't be stopped by this one. You will be stopped by this. So meaning this, it forms our top like fence or wall. We call it the top boundary. So now it will not be here. Now, if you want to go down, if you look down, if you are here, you try to go down or down here, it doesn't matter where you are. You will see this. If you want to go out, you will be prevented by this fence. It doesn't matter whether you are here straight down, you get stopped. If you are here straight down vertically, you'll be stopped by this. You are here straight down, you'll be stopped by part of this. It doesn't matter where you are inside the region, you will be prevented to get out by this. Therefore, this, which is y equal to 0, is our bottom boundary or bottom function. If that is the case, then to find the area of this, we will simply say that top. We will say now top function, let's say top f minus bottom f. Only if the whole region is bounded by a single function on top and a single function at the bottom. We use this. Only if the whole region that was asked to find its area is enclosed on top by one function, a single function, and at the bottom by another single function, like this one. So now, how to find the area? It will be the integral of the difference of these two functions. Let us pause here. Any question thus far? No question. If that is the case, then we're going to say we integrate with respect to x. If it is the top function minus the bottom function, then you say you integrate with respect to x. And from there, what now? It will now say what now? Can you integrate this difference? Because it will just be arbitrary function. In our case here, the top function, it will be 3. Because it's y equal to 3. The bottom function, because it's y equal to 0, therefore it will be 3 minus 0. But remember, this is just generally, it will be the top function. It will depend on what is that function. Minus the bottom function. It will depend on what is that function. And once you understand this, then we can take it to any region. But now the question, it will still be what? Can you integrate this? Good. But now, before we go far, now, this is x. dx. And this will be in terms of x. This will be in terms of x. And then we are now going to say, okay, this region is enclosed by which two vertical lines? It's enclosed by which two vertical lines? That is, it runs from which value of x on the left, runs until which value of x on the right side. So what is x? What is that function that forms your left boundary? Is x equal to 0? It starts here where x is equal to 0. It will continue with those values of x, continue with those values of x. What is the last value of x here? Anybody? What is the last value of x? That is the x3 is 4. Because they say from here to here is 4. But if it doesn't start at the origin, obviously you will have to calculate it. But this one is very simple because we are starting at 0. So therefore it will be up to x equal to 4. Everything's in terms of x. This is the lower boundary. We know it. Or we can now call it the when you are still dealing with the definite integral, we're saying the lower limit. But now here it will be the left boundary. This, in general, when you are still dealing with definite integral, you are calling it the upper limit. Now here we're going to call it what? The right boundary. But now, here now, we're not even writing x equal to 0. But I just wrote this so that you can see that everything is now in terms of x. dx, x equal to 0, x equal to y. Then this one, it will be y equal to the right side, it will be in terms of x. This is y equal to, and the right side, it will be in terms of x. So here, we don't even include x equal to, we just include what? We just write 0. But you must know that this 0 means x equal to 0. Here, you just write 4. But you must know that this 4 means x equal to 4. Then from here, what is the top function? Is y equal to 3. Y equal to 10. Then you write 3. Then this one here is the x-axis, which is y equal to 0. This is y equal to 3. Then we write the right side, which is 3, is y equal to 3. Y is the subject of the formula. Then the right side, you write it here. The same thing with this. Then from there, now you then integrate this. You then integrate this. Then you will get our 12. Hopefully this makes sense. Integrate 3 with respect to x. We know it. It will be 3x. Then this is definite integral. You evaluate this from 0 to 4. Then you get the answer. Obviously, we know here you open 2 brackets. In the first bracket, you write 3x, but with x replaced by 4. We know this. Then it will be 3 multiplied by 4. In the second bracket, you write the same thing, but with x replaced by 0. Therefore, it will be this. So what is the answer? The answer is 12 square units. Hopefully that makes sense. Any question before we go far? Any question? No question? Any question? Any question? And once you understand this, then you can run with this. That's good. Okay, let's go back now. Let us look at it from a different approach. Although it's not necessarily from a different approach, but now look at it. We have said if your region is enclosed by one function on top and one function at the bottom, one function on top and one function at the bottom, then you integrate with respect to x. Then we are going to say integrate the difference of the top function and the bottom function. But now, another way of looking at it, it will be what? A equal to, here, this function is enclosed on the right side by one function or by one curve. It's enclosed on the right side by one curve. It's enclosed on the left side by another one curve. Does it make sense thus far? It's enclosed. If you are here and you want to walk out of this region to the right side, if you are here, then you want to go to the right side, you will be stopped by the line x equal to 4, because this is the line x equal to 4. If you are here, then you want to walk out of this region to the right side, straight horizontally, you will be stopped by this. Here, you will be stopped by this. Here, you will be stopped by this. You are here, somewhere here. Then you want to walk out of this region. Then to the right side, you walk horizontally. You will be, doesn't matter where you are in this region, you will be stopped by this wall. Therefore, this line, x equal to 4, forms our right boundary. It doesn't matter where you are in the region. Hopefully that makes sense. But what about if you want to walk to the left side? You want to walk out on the left side. Say you are here. Walk horizontally to the left. You will be stopped by this. You are here. Walk straight horizontally to the left side. You will be stopped by this. You can't get out. You will be prevented by this wall, this fence, this boundary. It doesn't matter where you are inside the region. It doesn't matter where you are inside the region. If you try to walk straight to the left side, you can't. Why? Because of this. So therefore, this region is enclosed on the right side by one function or one curve. It's also enclosed on the left side by another one curve, irrespective of your position in the region. So if that is the case, then we're going to say integrate the difference of what? Of the right and the left. Does it make sense? Yes. If that is the case, then we're going to say you integrate with respect to y. Then from there you can finish it. Because once you say with respect to y, then you must now ask yourself, this region is enclosed by which two horizontal lines? It's enclosed by which two horizontal lines now? No longer vertical lines, which is x and x, but horizontal line, which is y and y. This region start where y is how much? It will be 0. And it will continue until where y is how much? It's 3.
3.
That's right. And this now, it must not be what? It must not be what? In terms of y. It must be y equal to 0, y equal to 3, and this it must be in terms of y, and this must be in terms of y. Meaning what? You must now take this, take this, and make x the subject of the formula. Take this and make x the subject of the formula, and write it in the form of x equal to. Maybe it will be x equal to 2y plus 6, we don't know. This line, maybe it's y, maybe it's x equal to 2y plus 6. The same thing this. Maybe it's y equal to y squared. Maybe this is y. No, it's how much? It's x equal to whatever. Y squared plus 3y plus 7. We don't know. But what we know is what? X is the subject of the formula. X is on the left side isolated. Then the other side, no X. So now here we know this. What is this line? Is X equal to 4. Therefore, the right side, it will be 4 because it's X equal to 4. Then you write 4 minus, what about the left side? This is X equal to 0. Then you write here 0. Then from there, you integrate this. I'm wrong. We shouldn't even say you integrated this. We must say you enjoy this. Then but don't forget, you are integrating with respect to y, not with respect to x.
To y.
That's right. So it will simply be what? The integral of this is 4(1). Then from 0 to 3, then the answer is what? It's 4 multiplied by 3, which is 12. We don't have to talk about it. It's 12. And as I'm saying, once you understand it is, then you will run with whatever. We can give you whatever. The big question, it will now be what? Can you integrate from here? From here now, can you get this answer? Because depending on this, then it will depend on which technique now you will use now, you will need to get this answer. Because if these are trigonometric functions, therefore you need to know how to integrate that. If this is exponential functions, then you know. If this is hyperbolic functions, then you must be able to integrate that difference. If it is simple what? Polynomials, then you should be able to integrate this. Hopefully that makes sense. If it does, then we can move on now and look at whatever now. Anything. We can integrate anything. As long as you get this. As long as you get this. Because there will be some regions where now you don't have a single function. You don't have a single function forming the top. Maybe you don't have a single function forming the bottom. Maybe you need to divide your region into sub-regions. Say from here to here, they have got what? A common top. And from here to here, you have another top. Therefore, A now, it will now be what? The sum of those, of the areas of those two sub-regions. And some, you may find that they are like symmetrical. One is from here to here, the top is this, and the bottom is this. And then the next region is what? You find that your functions now, they alternate now, they swap now. What was on top from here to here is now at the bottom from here to here. And what was at the bottom from here to here is now on top from here to here. That's good. Any question? No question. But as we have said, you please stop us at any moment. At any moment, you stop us, and we will try to clarify it further. Say you have something like this. Let's look at something standard that you know. Say you have got what? Say find the area of the region enclosed by the following f's. Say y equal to 2x. Find the area of the region enclosed by the following curves. Y equal to 2x. What? Say the x-axis. And what? Say here x equal to, no. Let's say x equal to 3. That's right. Can you sketch that region? Y equal to 2x. the x-axis and x equal to 3. This is going to be your fence, like your fence. One of your fence, it must be 2x. One of your boundary must be the x-axis. And another boundary must be the line x equal to 3. Can you sketch that region? Because that should be the starting point. I'm not sure about your curriculum, about your syllabus, whether in the exam, whether they will just ask you a question like this to say find the area of this, or they will schedule the area for you. No, okay, or they will schedule the region for you. Then from there, ask you just to find the area. Hopefully, I make sense. So, can you sketch it? Say a second. How many seconds you need to sketch this region? Because that will be the starting point. If they are not going to sketch the region for you, therefore your starting, you must be able to sketch it, be able to identify it, so that you can see which curve is going to form your top boundary. If that is the case, which curve is going to form your bottom boundary? So if it's one curve, the top, one curve, the bottom, therefore you are going to integrate with respect to x. If it is one curve, the right side, one curve, the left side, therefore you're going to integrate with respect to y. Therefore, the identification of the region is very, very, very important. So are you done? Hopefully you have got a pen and a pencil somewhere with you. This is mathematics. That is why we said what? Print the formula sheet, print what. Yeah, that's right. Are you done sketching it? Yes, then it will be something like this, more or less. It will be something like this. This is the line y equal to 2x. Then this is going to form one of your fence. It's going to form your fence, this. One of the fence or one of the boundaries. It's going to form it. Then the next thing is the x-axis. And where is the x-axis? This is the x-axis. This is the axis, which is going to be one of the fence of that region. So up to now, what will be that region that they're talking about here? Up to now, just this and this. What will be the region that they're talking about? The region whose one fence is this line, another fence is this line. For that region for now, it must be between, enclosed by this line and this line. Up to now, which region here are we talking about? Do you have any idea? Region, which region up to now are we talking about here? Definitely, it will be something here. Something here. Or what? Or something in between it is. Because they say one of the fence, it will be this. And the other fence is this one. That's right. So, but now, are we done with our fence, our boundary? Are we done? No. They say this is also a boundary. That is this line here, x equal to 3, is also a boundary. So obviously then this is out. You see, this is out. Therefore, the region they're talking about is this one. This is the region that they're talking about, is this one. And because this is the line x is equal to 3, therefore this is a right angle, because it's x equal to 3 and y equal to 0. X equal to 3 and y is equal to 3, y equal to 0. They're perpendicular to each other. It's a vertical line and a horizontal line, perpendicular to each other. Therefore, this is a right-angled triangle. No, this is a right angle. Therefore, this is a right-angled triangle. The whole is a right-angled triangle. And this is a right angle. Therefore, sides using integration, because now this is standard. because it's a right-angled triangle. Therefore, we can what now? We can use those standard formula. Where one of them is how much now? Is half, if I remember well, multiplied by what? The perpendicular height, because it's a right-angled triangle. We don't have to construct anything because this is this and this is horizontal, this is vertical. Therefore, the height here, it will be the length of this. From here to here, it will be the length of this. And then what now? What? By the base. And what is the base? This, it will be the height, and this, it will be what? The base. So, which is very simple now. What is the height? Obviously, it will be from here to here. Therefore, it will be y from here to here. Don't forget that. What is x? X is from here to here is 3, because they say this is the line x is equal to 3, meaning from here to here is 3. Then what is x here? What is x here? X is equal to 3, or simply put, this is the point of intersection between y equal to 2x and x is equal to 3. This is a point of intersection. It's a point of intersection of the line y equal to 2x and the line x is equal to 3. Therefore, it's just how much? Simultaneous equation. But this, because it's just x is equal to 3, then you just come and replace x here by 3. Although generally, it will be how to find the point of intersection of two curves. The point of intersection of two curves, it will be via simultaneous equation. But here we can't even talk about simultaneous equation because this is just x is equal to 3. Then you're going to replace x here by 3, you get 6. Therefore, from here to here is how much? Is 6. From here to here is how much? Is 3. Then you can now find what? You can now find this. Although in here, this is not even necessary. It's not even necessary because all what we need is what? The height. What is the height? The height is 6. And what is the base? That is this length. Is how much? Is 3. Therefore, what is the answer here? It will be 9. Half multiplied by 6 multiplied by 3. It will now be what? 9. That is square units. Don't forget that. Square units. That's good. But now, using integral methods, what would be the answer? Using integral methods. And then you see now, you look at this and say, if I'm anywhere in the region, it doesn't matter where in the region, or this region, okay. If you are here and you want to go up, you're going to be stopped by something. You're going to be prevented by a certain fence. You're going to be prevented by a certain wall or whatever. So what is that wall? If you are here, you want to get out vertically, you're going to be prevented by part of this because it's y equal to 2x. Anywhere here is y equal to 2x. Here, y equal to 2x. You're going to be stopped by this line, which is y equal to x. If you are here, you want to go up, you're going to be stopped by this. If you are here, stopped, here, stop, here, stop, here, stop by this. What about the bottom? You are here, bottom, stopped by this. Here, bottom, stop by this. Here, bottom, stop by this. Here, stop by this. Stop by this. Stop by this. Therefore, this is enclosed at the top by a single graph. It's enclosed at the bottom by another single graph. Therefore, the area now, it will be what now? If that is the case. On top, stop by this. At the bottom, stop. Then it will be integrate. Then it will be with respect to x. Then we are now going to find the difference of what? Integrate the difference of what? The top function and the bottom function. What is the top function? Now you write those functions in terms of x. Meaning it must now be, you must now rewrite them as y equal to something, y equal to something. Then you find the difference, you integrate the difference of the right side. This is how much is y equal to 2x. Then you write this. Then it will be 2x. This now is y equal to 0. Then you write this minus 0. That's good. Then you say this region is enclosed by which vertical lines? Is x. Then it must be enclosed by which two vertical lines? On the left side, what is the smallest x on the left side? The smallest x here is 0. And then on the right side of this, what is the biggest x? Is 3. Then you integrate this. Then you will get your 9. It will simply be what? The integral of this, it will just be x squared from 0 to 3. Integrate 2x is x squared. It is just 9. Hopefully that makes sense. Does it make sense? Yes, it does. Hopefully it makes sense. But now, let's say this. Are we together? The same story. Can we integrate here with respect? Can we change this to dy? Let us hear you. That is, this region is enclosed on the right side by a single function and on the left side by a single function. Which boundary form the right side in this region? It will be x equal to 3. Doesn't matter where. If you are here, you want to get out here horizontally to the right side, you will be stopped by x equal to 3. Stop by x equal to 3. Stop by x equal to 3. Stop by x equal to 3. But what about the left side? You will be stopped by this. Stop by this. Stop by this. Stop by this. Meaning you must now come here, make x the subject of the formula. Meaning from here, you must now make x the subject of the formula. It will now be x equal to y over 2. Then we are going to write this as x equal to how much? That is y over 2. This is x equal to 3. This is x equal to 3. This is going to be x equal to 3. Therefore, it will be this minus this. It will be this minus, that is here, here, here. It will now be a equal to the integral of, now it will be dy. Now it will be y over 2 is the right, minus 3 is the left. No. It's the other way around, right? It's not it is. It will now be what? Hopefully we're together. It will be the right side, it will be x equal to 3. Therefore, it will be 3 minus y over 2. It will be this. Because this is our right boundary. This is our right boundary. If you are here, you want to go out, it will be 3 minus. But from where to where? You are looking at y. You will now look at this and say, what is the smallest value of y in this region? You write it here. And what is the biggest value of y in this region? You write it here and then you integrate it. In other words, this region is enclosed by which two horizontal lines? This, it will be the smallest value of y. This is the biggest value of y here. Y here is the biggest value of y in this region. So this is how much? Y equal to 0. Now what about this one here? What is this horizontal line? It will be what? It's y here. We know what is y here. It's how much? It is 6. We know if x here is 3, y is 6. Then you integrate this. Then it will still give you 9. It will still give you 9. No ways. It must give you 9. It must give you 9. It doesn't matter. It must give you 9. Okay, now let us take this. Now be serious now. Hopefully, yes. And as we have said, once you understand this, once you understand how to get this, then you can answer any question. Provided you'll be able to do what? To identify that region that they're talking about. That is number one. Number two, be able to do what? To construct that integral formula. Hopefully, be able to integrate using those integration technique. And from there, you get an answer. Okay, let us say this. Find the area of the region enclosed by the following curves. I don't have to write everything. The question is, find the area of the region bounded by the following curves. What is the first one? Y squared equal to 8x. This is going to form one of your fence. Then you must be able to sketch it. In case in the exam it's not sketched for you. What is this? Can you sketch this? Can you sketch this? Tell us how it will look like. Anybody? Just tell us how
Sorry, I can't see properly. Is that y squared is equal to 8x?
Yeah, y is equal to 8x. Y squared equal to 8x. Can you sketch this? Y squared equal to 8x. The answer is it yes? Is your answer no? Or is your answer somewhere in between? No. You must be able to sketch this. No. You must be able to sketch this. Otherwise, then you are in trouble. No, you know how to sketch this. No, tell me. Y is equal to x squared. Can you sketch this? 8y is equal to x squared. Because if you can sketch this one, then you can sketch this one. That is, can you sketch y equal to 1 over 8x squared? Because this is equivalent to this. If 8y is equal to x squared, therefore y is equal to 1 over 8x squared. Can you sketch this one? Let us be serious,
Yes.
eh? Can you sketch it? I mean, if you want to. Surely you can sketch this. Everybody can sketch this. This, it will simply be what? A vertical parabola like this. This is this. It's like y equal to x squared. You can't differentiate the graph of this one and this one. Unless if they are drawn on the same side of axis. If they are not drawn on the same side of axis, because they have the same shape, they will all look like this. Unless if they are drawn on the same side of axis. If they're drawn on the same side of axis, then this one is going to be compressed now vertically. Because now the y values of this one, they will increase faster than this one. Because you are going to take this and multiply it by 1 over 8. Meaning you are going to take y here and divide it by 8. You are going to take y here and make it smaller because you're going to divide it, because this is a positive number. Then if it is a positive number, then you divide it by 8, then it will be positive. It will be less than. That's right. Therefore, if they are drawn on the same set of axes, then it will be this. It will be this. This is going to sit inside this one. This is going to be this. It's going to sit inside. You see. Unlike if you've got y, another one here, say y equal to x squared. Where will this one be? Y equal to x squared relative to these two. Is it going to be outside? Is it going to be in between? Or is it going to be inside? Just tell me. This one, y equal to 8x squared relative to this one. Is it going to be outside? Is it going to be in between these two? Or is it going to be inside this? Anybody?
I think it's gonna be inside.
It's going to be inside. Yes. It's going to be somewhere here, inside. No, is it inside? Yes. Because we are going to take the y value here and multiply it by 8. Let's say x here is 2. If x here is 2, if x is 2, if x here is 2, what is y? It will be 4. But what about this now? If x is 2, what is y? Is it bigger than this one or what? Yes, it's going to be bigger than this one. It's going to be 32. Therefore, this one is this one stretched vertically, pulled vertically. What about this one and this one? This is this one, but compressed vertically, meaning stretched horizontally. So, but now, this is not today's topic, but unfortunately, if the sketch is not given, you must be able to draw this and be able to identify that region, and thereafter is then that you will be able to what now? To calculate the area. But if the sketch is given, then you can just see from the sketch. So this region has got what? Top boundary, and then at the bottom, there is a single boundary. Therefore, you're going to integrate with respect to x. Integrate what? The difference of that top and the bottom. Or in this region, it has got what? 1 right, 1 left. Therefore, you're going to integrate the difference of the right and the left, integrate with respect to y. Or I need to subdivide my region into 2 or into 3, so on and so forth. But if the sketch, therefore, it will be your task to sketch the graph first. Now, if you know this one, if you know this, then you should be able to sketch this one. Because this one is just this one, what? This one is vertical. This one is vertical. This one is this. This one is this one. This one, vertical is this one. What about this one? This one, it will be now be what? It will be this one.
Horizontal.
That's right. It will be this. Let us take this out so that it doesn't have to confuse us. It will be this. That's good. Then you sketch it. Then you know one of the fence, it will be this. This is going to form one fence. And from here, you can pause and say, therefore, what will be my region so far? Because this is a fence. Therefore, my region is going to be everything inside. It's going to be everything inside here. Or what? Everything outside. Because this is going to be the all. Is the all. Then what is the other one? They say and what? 2x minus y equal to 0. This is going to be one of the fence, one of the boundary, one of the walls. Then you sketch this. Sketch this. It is simple, 2x minus y equal to 0. Then it will simply be what? 2x is equal to y, or y is equal to 2x. Then you draw the line y equal to 2x. Then it will simply be what? Simply be this line, y equal to x. Something like this. It will be, let me just draw a nice thing. It will be this. This is our Cartesian plane. Good. And this is our y equal to 2x. It's good, more or less. And then from there, it will be that horizontal parabola. More or less it is. That horizontal parabola. So which region here are we talking about? Two curves. Which region here are we talking about? Definitely it will be this region. Definitely it will be this region. That's right. Now then you pause now. You have identified. That's good. Then what is the next task? Or are we still together here? Then
Yes,
your
sir.
next task, it will not be what? Is it what? Is it going to be the top minus the bottom? Or is it going to be the right minus the left? Now you imagine yourself standing anywhere here. It can be here, 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 it can be here. Then you want to get out of this region through the roof. You want to go up. You want to go up. Anyway, you want to go up. You will be stopped by what? And is it going to be two out? You're going to be stopped by what? Anybody? I'm here.
If I want to go up,
Yes.
I'm gonna be stopped by the one for y squared is equals to 8x.
That's right. Now, what about here when I'm here? By the same function. What about here?
Yes.
The same function. Anyway,
same function.
Anyway, you are going to be stopped by this. Y squared equal to 8x. Anyway, you're going to be stopped by this. But what about if you want to go down? Any position in that region, inside the region. You imagine yourself standing or sitting or sleeping at any point in any position inside the region. Then you want to go down. You fell, then you go down. It must be vertical straight. You're standing here and then you fell. Then you go vertically down. You will be stopped by something. You will be stopped by what?
My 2x is equals to y.
It will be stopped by this. It will depend on your position on this. If you are here, you will be stopped by here. Stopped by. Then, therefore, you'll be stopped by what? You'll be stopped by y equal to 2x. Then, if that is the case, then we are going to integrate with respect to what? With respect to x. Therefore, the answer here, it will now be a equal to the integral of what now with respect to x. You see, integral of what with respect to x. So what is the top function? Then this is not y equal to. You must write it as y equal to. And this is not y equal to. Like what we did here, we wrote it as y equal to. Then here you make y the subject of the formula. Therefore, it will be y equal to how much? The square root of 8x.
Plus or minus square root of 8x.
No, it can't be plus or minus. Because
because we are using only the top part, so we're gonna use the positive one.
That's right. Because this one is the one that is where y is minus. This part below is the one that is where y is minus. Therefore, here you can say plus or minus because you are using the portion where y is positive. Then you can just rewrite it nicely. I mean, for integration purpose, because at the end you are going to integrate. Therefore, it will be better to write this as what? Or to see it as what? As the square root of 8 by the square root of x, which is x exponent half. I mean, for integration purpose, because you know you're going to integrate. So therefore, this will be how much? The square root of 8 by x exponent half minus what? Hopefully you can still see. This is the square root of 8, that is this one. This is the square root of x for integration purpose. Let us write it as x exponent half. Then minus what? This now, which is how much? Which is 2x. Then you now go back to the region and say, what is the smallest value of x here? This region is enclosed by which two vertical lines? is enclosed by this. This, it will give you your small x, enclosed by this, because this is the last x. And obviously, this is the point of intersection. This is the point of intersection of this and this. That is the point of intersection of this one and this one. And therefore, you have to find what? That point of intersection. That will be simultaneous equation. 1 point, it will be this. This and this. They cross each other at the origin, at 0 and 0. And they cross each other at this point. And that we're interested in x here. So therefore, it will start from 0 up to what? Then you take this to find x here. Is 2x equal to y. And because this y, y here is the subject of the formula, then you just say, oh, if y is this, then what is y squared? Then you come and replace it here. Y is 2x. Therefore, what is y squared? Which must come here, because we want to find x here. So therefore, if y is this, then what is y squared? It's 4x. 4x squared equal to how much? 8x. And from there, that is quadratic equation you solve for x. Obviously, it will be minus equal to 0. Then it will be 4x in brackets x minus 2 equal to 0. Hopefully, you can still see. Then 1x here, it will be 0. That is at the origin.
X is
Another
equal to
x
2.
here, it will be 2. Therefore, it will be from here to 2. Hopefully, you can still see. Then you integrate this. This is standard, straightforward. Then you evaluate it. Remember, you are going to integrate with respect to x. Any question thus far? No, we don't have to finish it, isn't it? We can all finish
No,
it.
it's fine.
It's fine. But now the question is, can we integrate with respect to y here? I mean, we're just playing around with this. Can we integrate with respect to y here? That is what? If I'm here, anywhere here, and I want to exit this from the right side, I'm here. I want to get out here, then I want to move horizontally. Which function or which curve will stop me? And is it going to be the same curve, irrespective of your position inside the region? That is what is very important. If I'm here, which function? I want to go to the right side, horizontally. Am I going to be stopped by the same function as I'm here? As I'm here? The same function for somebody who's here? The same function by somebody who's here? That is irrespective of your position inside the region. Will you be prevented by the same function? That is what is important. If yes, then what is that function? And because we are now saying horizontally, therefore we must talk about x. That is, we must now make x the subject of the formula. If vertically, either up or down, you make y the subject of the formula, because you are talking about the vertical distance. Vertical distance. Now, because here you are not talking about the horizontal distance. Horizontal distance. Therefore, you make x the subject of your formula. Your formula must be defined by x equal to. Then on the other side, it will be y. Are we going to be stopped by the same function on the right side? Yes, you can say no. You can say I don't know. We are all saying yes. Not just yes, capital yes. If you are here, it will be this. That is 2x equal to y. If you are here, it's still 2x equal to y. 2x equal to y. 2x equal to y. Therefore, you're going to make x the subject of the formula. That is, rewrite this equal to
X is equals to y over 2.
That's right. What about the left side? If you are here, then you want to run out of this horizontally. You can't. You'll be prevented by, you can't. You are here, you want to exit. You are here, you want to exit. You are here, you want to exit. You are bounded by what on the left side? By part of this. Part of this. But it will be this section, only this part, only this, only from here to here, because we are talking about this region, only from here to here. So because it's the left side, then it must write like here. We must now write this as x equal to. Write this as x equal to. Therefore, it will be x equal
Y
to how much?
squared over 8.
Over 8. Therefore, it will be a equal to how much then? Then we are going to integrate with respect to y. We are going to integrate with respect to y. Then this, it must now be the right boundary. What is the right boundary here? Y over 2. Minus the left boundary. What is the left boundary? Y squared over 8.
8.
Then we are now going to say this region is enclosed by which two horizontal lines? Which two horizontal lines? Everything must be y. What is the smallest value of y here? Because it starts here, the region starts here, it continues until y here. It's enclosed between these two horizontal lines. It's enclosed between these two, this horizontal line and this horizontal line. It's between
So the
these two
lower bound
horizontal
is
lines.
0.
Yes, it's between these two horizontal lines. So what is this one? Y equal to 0. And what
And
is
the
this
other one
one?
is 4. 4.
We know x here. We know x is 2. If x here is 2, then what is y? You can either replace it here or replace it here. They will give you the same answer. What is y? It's 4. Replace it here. X is 2. X is 2. Then it will be 2 by 2, 4. Then you integrate this. You see, this and this, they're going to give you the same answer. This one and this one, they're going to give you the same answer. They're going to give you the same answer. No ways. If not, then we throw mathematics out of the window. It's meaningless. It's confusing. That's good. That is good. We don't even have to finish this, because what is important is constructing this. Once you can construct this, then you are done. Then you are done. Starting with be able to sketch that region. That is, be able to sketch the curves, and from there, identify the region. Then from there, ask yourself now, do I have, is my region enclosed by one function on top and one function at the bottom? If that is the case, you integrate with respect to x. Everything will be in terms of x. Meaning you have to go back now, rewrite your curves as y equal to something, y equal to something. If your region is enclosed by one curve on the right side and a single curve on the left side, that's right. Then you're going to integrate with respect to y. Therefore, you have to rewrite your curves as x equal to and x equal to. And take the right side, subtract the left side. No. Take the right curve and subtract the left curve. And from there, ask yourself, your region, where does it start? What is y there? Runs until what? The biggest value of y. Then now, to integrate that difference now, it will now go, you will now have to go back to what? Those previous sessions. It will depend on those functions now. Okay. Now, let us look at another one. Or is there any question before the next one? Any question? Any question?
No, sir.
Any question? No question? No question. Perfect. It's good. Another one here. Let's say you have this. Don't forget, what is the question? Find the area of the region enclosed by the following curves. Find the area of the region bounded by the following curves. Now I'm writing curves now. I'm simply writing just the curves. Y equal to how much here? Say 2 over what? Say 2 over x plus 1. Let us pause here. This is going to form one of your fence. Can you schedule this? Y equal to 2 over x plus 1. Although that is not today's topic. Today's topic is what? We assume you can schedule this. That is today's topic. We assume that you can schedule this. But can you schedule it? Just 2 seconds. Just try. Hopefully you have got a pen and pencil there. No AI, no AI, please. No AI. Your name is not AI. I don't see anybody's name here as AI. I'm only seeing Sevashe, what Sipo. I'm only seeing, you see Hendrik. I'm only seeing Tawang, whatever. There's no AI. Therefore, please don't use AI. Ne? That's good. Are you done sketching this? Tell us when you are changing this. Y equal to 2 over x plus 1. Don't forget
Yes.
the mother graph of this, because this is shifted. The mother graph is y equal to 2 over x. Can you sketch this? That is, the mother graph
Yes,
is xy equal to 2. Is xy equal to 2? Then if you make y the subject of the formula, then it becomes this. Now from there, you take this and you replace x by x plus 1. You replace x by x plus 1, then it becomes this. You see. So can we all scale this? Can we all scale this one? Yes. This, it will simply be this one. We know it. It is simply this. It is simply this. The vertical asymptote is x equal to 0. You let x be equal to 0 because the denominator cannot be equal to 0. Then you let x be equal to 0. Why? Or you can just say x cannot be equal to 0. Therefore, this is our vertical asymptote. This is our vertical asymptote. You are to this, getting closer and closer to this. That's good. And at the same time, y cannot be equal to 0, meaning your graph cannot touch the x-axis, because if you replace y here by 0, try to solve x. Replace y here by 0, because you are now looking for the y-intercept. Can we find the y-intercept? Does it have the y-intercept? No. Does it have the x-intercept? No. Because if you replace y here by 0 and try to solve x, there is no x. It will disappear. Therefore, there is no x-intercept. Can we find the y-intercept? That is, can we replace x here by 0? No, it will be y equal to 2 over 0, which is undefined. Therefore, this, it will be this. But now, what about this one now? What about this? It will simply be this shifted 1 unit to the left. We know this. Therefore, this one now, you just take this, and shift it 1 unit to the left. That is good. Therefore, the graph of this one, it will simply be this one. Okay, let us get the what? Let's say the y. What is the y-intercept here? You replace x by 0. Therefore, it will be 2. Therefore, your graph, it will be something like this. And what? What is the vertical asymptote? the vertical asymptote, it will be x equal to -1. X equal to -1. Therefore, your graph, it will be something like this. Hopefully this makes sense. Your graph, it will be something like this. That is your graph, it will be something like this. Where this somewhere here, what is the y-intercept? The y-intercept is 2. And this is your new vertical asymptote, x equal to -1. Does it have the x-intercept? No, because the x-intercept here, to find the x-intercept, you're going to replace y by 0. If you replace y by 0, can we solve for x? No. X will disappear because it will be 0 multiplied by this. Therefore, it will be 2 equal to 0. Can 2 be 0? No ways. 2 will never be equal to 0. 2 has never been 0. It's not equal to 0, and it will never be equal to 0. Meaning, you will never have the x-intercept because x will never be equal to 0. Therefore, you will never have the x-intercept. That's good. This is only this. Meaning, you now pause now. You now pause and say, okay, this is going to be one of my fence. This is going to be one of your fence. Therefore, what is the possible region? If this is one of your fence, this is one of your fence, you see. Then what is the possible region? Hold that thought. Now, what is another curve? What is another curve? Another curve is y equal to x. Another boundary is y equal to x. Then you sketch it. Where is the line y equal to x? This is the line y equal to x. Let me use another color. The line y equal to x. It will simply be this line. It's one of the boundaries. One of the boundaries. This is going to be one of the fence. And next, x equal to 3. One of the fence is x equal to 3. Let me use, let us use another color. X equal to 3, that is this. And another one, the x-axis. That is this. So which region are we talking about here? Which region here? And now let's read it further. Let's say in the first quadrant. They say that region is in the first quadrant. Can you identify it now? I've written all the boundaries. I've written all the fences. So if you still cannot identify that region, yes, then you are in trouble then. Can we all identify that fence or not that region? Can we? Carlos?
Yes, we can.
Which region is it? Anybody? Brenda, which region is it?
Since you said x is y is equals to x and x is equals to 3, so if you have the 2, then there's one that is up, then it's like a triangle. I don't know how to say it.
The good thing is,
x equals to 3 is a bound, is a closed thing, and that line way it goes down from 2 and close it, and the one of y x is equals to x enclose it. I don't know if you can you put your finger there so I can tell you which area? No, on the first quadrant, say.
On the first quadrant.
Yeah. So move from there. You are going there.
One? Is it this one? Is it this one? Is it this one?
Yes.
Is it this one? Carlos? You see now. Now we got Carlos. He just switched on. Now he's going to buy order now. You see, he's gone.
I'm here, man.
I think,
Oh, you are
I
back.
think that is the
Is
right
it this
one.
one? Is it this one, the region that we're talking about? Is it this one that is enclosed by all these steps? Don't forget that we are asking you, Carlos, ne? Yes.
Yes, sir. Yes, sir. I'm listening.
Yes. My number question is the region this one? Is it the region? Is it this one? No. 3, 2, 1, gone. Kuto, is that the region this one?
No.
No.
It's the
Sebastian?
one, it's actually the one, it's the area below the shaded area.
It's the region below.
Between the x-axis, but just below the shaded area.
Yeah, you see, Brenda. You said this one,
Yes, sir.
including Carlos. But now the question is the x-axis and a boundary of this region?
I didn't see the other one. Sorry, sir. I only used the two.
Okay. In the
Oh, there's
exam,
X.
you must see everything in the exam. For now, you are
But
forgetting.
then writing will
But
be
now,
close in the exam, sir.
yeah, that's right. You must wear glasses even in the exam. You see, this one is wrong. Why? Because the x-axis must be a boundary, and it's not a boundary here. Therefore, the only correct region, hopefully you are listening, Mahlatsi, the only correct region here, it will be what? It will be, who got it right? I can't remember. I'm getting old. No, it's not Carlos. Carlos, you got it 0, ne?
It's me.
Yes, you got it 0. Carlos, don't change. You got it 0. So who got it right?
It's me.
Kujo. Oh yeah,
Kujo.
that's right. That's right. Kujo. Is this region? It is this. What? This part, they say in the first quadrant. Therefore, we can't even talk about it, the other quadrants in the first quadrant. Although that is the only region that has got all these boundaries. It's in the first quadrant. Even without saying it's in the first quadrant, there is no that is got all of this as its boundary. This, it must be a boundary. This must be a boundary. This must be a boundary. This one must be a boundary. So definitely it must be in the first quadrant. Therefore, this one, we can even take it out because it doesn't add anything. Maybe just a hint to say it's in the first quadrant. That's good. Now, is it a standard feature, this one? Do we have, it's a formula standard? Is it a rectangle? No. Is it a circle? No. What? Therefore, good. It will be integration. Now you pause now. Look at this region. You pause now. If I'm anywhere in here, will I have what? The top boundary. If I'm, say, somewhere here, somewhere here, and I want to go out vertically, which function, which curve will stop me? I'm here, and I want to get out of this region vertically. Which function, which curve will stop me? Kavani, Clifford?
Y is equal to X.
Y equal to how much? That is this. It will be Y equal to X.
Equal to X.
But if I come and stand here, will I still be stopped by Y equal to X? If I come and stand here. Because here I couldn't. Y equal to X prevented me. Then I'm like, what, clever. Then I move from here and then come and stand here. And I want to do the same thing. Go out vertically. Still be Y equal to X. That will prevent me from getting.
No.
The answer is what? No. It's no longer going to be Y equal to X. It's now which function? It's now this.
Y is equal to 2. over x
2
plus
over
1.
X plus 1. Therefore, here we cannot even go far because this is not enclosed on top by a single function. Therefore, you cannot simply say what? The top function, because which one now? Because it's different tops. So here is y equal to x. Here is y equal to 2 over x plus 1. So therefore, which you see, that is where the problem. You cannot say what? Top minus the bottom. We can't even go to say the bottom because we single top. But if you go to what? The x-axis. Here, the bottom, the x-axis. And in fact, any position here, any decision, if you want to go down, you will be stopped by the x-axis. Therefore, we've got a single bottom. We've got a single bottom. There's no argument about that. What about a single top? No, we don't have a single. Then we pause it. We pause it. Now we say, what about the right and left? We have a single right. Let us start it. Single right? Do we have a single right? So, do we have a single right? So now is now gone now. Do we have a single right here?
Yes.
Gone,
Yes.
Oh, I don't agree with you. It's not to say you are wrong. It's just that I don't agree with you. Check properly. Uti, Mavuja, do we have a single right? Pretend as if you are in the exam, Puti. Do you have a single right?
Yes, we have a single right.
You are also wrong. This is not politics. We are not going to say at the end, say, who said single right, therefore single right have it. No. What is that single right? Let's say you are here. You are here. You are here. Then you want to get out of this on the right side. Then you walk horizontally. You will be able to by this. Stop. But if you are here, then I walk horizontally. Am I still going to be stopped by this? No, I'm not going to be stopped by this. X equal to 3. Therefore, here we can say right minus left. But for argument's sake, if you are here, then you want to go to the left. You'll be stopped by this. Here, you'll be stopped by this. Here, stopped by this. Here, stopped by this. Here, stopped by this. Therefore, we have got a single left. One left. We will all, irrespective of our position, we will all be stopped by this y equal to x. But what about the right side? It will depend on your position. If you are here, you will be stopped by x equal to 3. But if you are here, you are going to stop by what? A different function. That is, you're going to be stopped by y equal to 2 over x plus 1. Therefore, we don't have a single right. Then what do? You can't say, no, we don't do anything. This is one of those regions where now you have to subdivide it. To say, okay, from here to here, I've got a single top and a single bottom. And from here to here, I've got another top and maybe still the same bottom or another bottom. Therefore, the area, it will not be what? The sum of those two subregions. Hopefully this makes sense. If not, you tell us. Does it make sense, Carlos? See, Carlos gone. So what do we do now? You can see that if you subdivide this here, 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 this you call it A1, and this one you call it A2. Therefore, if you are in region A1, although A1 I was thinking of the area, but it doesn't matter. So if you are in A1, we are going to have a single top and a single bottom. If you are in A2, that is this now, only this, it will be the same top and the same bottom, irrespective. It will be the single top and the single bottom. Therefore, A now, the area A, it will not be, find the area of plus this. It will be this. Does it make sense? And
Yes,
in both, it will not be top function minus the bottom function. You just have to find because this is x equal to 3. You just have to find x here, this vertical line that is dividing your region. And obviously, this vertical line, it will be x equal to something. And how do you find x here? Then we can say, oh, x here is the point of intersection of y equal to x and y equal to how much? 2 over x. This x here, this point here is the point of intersection of this y equal to x and this y equal to 2 over x plus 1. And if you take these two, and solve what? X and y simultaneously, they're going to give you 2 points because they intersect this line and these two. They intersect twice. They intersect here where both x and y are positive, and again they intersect here again where both x and y are minus, negatives. But we are looking for this one. Therefore, from here, then it will be the integral of what now? With respect to x. We just have to find the point of intersection here. So what will be the top here? The top here, it will be the top. It will be y equal to x. Minus, what is the bottom here? Y equal to 0. From this region now, it runs from where what? From where x equal to 0 until where, what is x here? Then you write it, because now you just have, remember, this is just what here, simultaneous equation, y is x. Then you come here, you replace y by x. Then you cross multiply, it will give you x squared plus x minus 2 equal to 0. I mean, I've already taken the 2 decide. Do this, it will be x plus 2, x minus 1 equal to 0. 1x is minus 2, then it will be this. Another x, it will be 1, which is this one. Therefore, it will be from 0 to 1. You get the answer here. Plus the integral of this region now. It is still the top minus the bottom. So it will not be what? What is the top now? The top is this, which is how much? 2 over x plus 1 with respect to x. Then you ask yourself, this region now is enclosed by which 2 vertical lines? What is x here? X here is 1. Until x here is 3. Then you integrate this. And then you can see that this is going to be lean, because this is the derivative over the function. You just have to take the 2 out. It will be exactly this technique now. It will be exactly this. Is the derivative over the function. If you say is the function, remember 2 is out. If it is the function, that is f, what will be is derivative? Is derivative to be 1. Then you integrate these two. Then you get the sum of these two. Then that will be the answer. Any question? Any question? Do we even have to finish this? Do we even have to finish this, Sebastian?
No, sir.
No. Thank you very much. I'm telling you, what a relief. I was just thinking, what if Sebastian says, no, say, let us finish it. What am I going to say now? See? sometimes you must be wary of what asking these questions. You ask thinking, you ask hoping that Sebastian will say no. And then Sebastian comes and say, yes, let us finish it. Now, what are you going to do now? Are you going to try and convince Sebastian? Now, don't forget, let's say whatever. I don't know what to write here now. Do you have any particular question? Any question? Do you have a question? I mean, so that we can, because I'm seeing the time here, so that we can ask, we can answer that particular question. Do you have any specific question, Brenda? My assumption is you went through all those exercises in your material, even with the past question paper or whatever. And then if you have that specific question about the area, don't forget that, about the area, then we can use these last minutes now to look at that. Do you have any specific question, Brenda? 3,
On my
2,
side, no, sir.
1, gone. Carlos? Any? 3, 2, 1, gone. Lilaga? 3, 2, 1. Sebastian is yours. 3, 2, 1, gone. Pala? 3, 2, 1, Puti. 3, 2, 1, Masatsi. 3, 2, 1, Tabani. 3, 2, 1, Sebiso.
There's someone talking, sir. Sir, there's someone asking a question.
Yes. What is your question? Oh, don't worry, Brenda, you heard me, ne? Then you thought it's somebody, ne? It was me.
No, there's someone who was saying sir in the background.
Okay. Any question? You see, I told you, Brenda, that it was me. You heard me, then you thought it's somebody in the background. There's nobody here. There's no any question? Do you have a question? Again? Sebiso? No. Okay. Sometimes you can have something like this. Yes, I think. Let's think. I'm just looking here. Say what? It's defined by this. I just want to give you something where one part is above the x-axis, then the other one is below the x-axis. Because if you're not careful, you're going to get the answer is 0, which doesn't make sense. Okay. Find the area of the region which is enclosed by y equal to sine x. Can you sketch that graph? Y equal to sine x. Y equal to sine x, we all know it. It will be something like this. On and so forth. You say from where to where? Say from and what? Say and the x-axis is enclosed by the graph y equal to sine x. That is y equal to sine x. And then they say the x-axis. That is this. That is this. Can you identify that region for now? Yes, it will be what? It will be this. But don't forget, this is still going. It will be this. It will be this. So on and so forth. Remember, this is still continuing. This is still continuing. But now, they say what? They say from x equal to 0. And once they say x equal to 0, then already we know our unit, the measuring unit. If they say x is equal to 0, can you say the angle here is measured in degrees? No, because they're not saying x equal to 0 degrees. Therefore, you must be careful. If you are using a calculator, make sure that your calculator is in radians unit, not in degrees unit. from x equal to 0 to what? X equal to, say, x equal to pi. Let's say 2 pi. Let's say 2 pi. Good. So which regions now are we talking about here? Don't forget, what is x here? Pi over 2, x here, pi, x here, over 2. Mean what now? They want us to sketch? No, they want us to find the area of this now, of these two. Find the area of these two. Does it make sense? Yes, it does. Do you like it? Yes, you do. You like it. Good now. Now you can see that, no, this region now here, we don't even have to talk about, is it bounded by what? No, you can see that in this one, the top function is sine x. The bottom is the x-axis. But now the x-axis. The bottom is sine x. When you say this is like A1 and this is like A2. Here it will be sine x minus 0. Integrate from 0 up to pi. This one is now 0 minus sine x. Integrate from pi up to 2 pi. Does it make sense? Then it will now be a equal to the integral of, it will now be a equal to a1 plus a2, which is the integral of sine x now with respect to x from y, from 0 up to pi, plus what? Sine, no, up to what? Because this is sine, this is just sine x minus 0. Sine x minus 0. There's no problem.
But now we have to introduce a negative because now that one is in the lower. We don't do area
Yes.
with the negative. Now we must introduce a negative.
Yeah, it will be this now. From pi up to pi, up to 2 pi. I saw a message here. Can you just, I saw a message here.
No, the person was like, it's gonna go now because there is no electricity where they are.
Okay, it's about to die. I'm sorry. Oh, I thought they have sorted out this load shedding. Okay. And we are just about to finish because we have got what? About we are left with only a few minutes now. About 8 minutes or so. Now you integrate it. There's no problem. Everybody can integrate it, including myself. That's good. Or if you see this region, this one and this one, they are symmetrical. They will have the same value. 1 and A2, they will have the same value. If the answer here is 4, then this one will also be 4. So if that is the case, you can see that this one and this one are symmetrical, meaning they will have the same area value. Therefore, there's no need to do the say A1 and A2. You can just say A is equal to 2 multiplied by what? Then you evaluate only one. You evaluate only A1 or only A2, depending on which one is simple. Does it make sense now here? Only if this 2 is to say what? Because this one, if the answer is 4 here, and then the answer is 4 here, then the final answer is just simply what? 4 multiplied by 2. You don't have to
Actually,
say
the answer is
here.
2, so altogether is 4.
That's right. Or if the answer here is 5, then the answer here is going to be 5, which is 10, which is 5 multiplied by 2. Therefore, all what you can do is what? Just find 1 and multiply it by 2. And you don't have to bring the 2 at the end. You can just bring the 2 here. Say out to 2, multiply by, then you get 1. You either integrate, get an answer for A1, for A2, depending on which one according to you, it will be very simple. And obviously, the one that will be simple, it will be what? The one that started at 0. The one that has got one limit is 0. Therefore, it will simply be this one. That you say sine x. Because it's minus 0, don't even have to say sine x minus 0. Then you integrate with respect to x, then you say from 0 to what? To pi, then you get the answer. Therefore, it will be this, which is this part. You get an answer is 5. Therefore, the final answer, it will be 5 multiplied by 2. That is for argument's sake. Like if you have got something like this, maybe this is minus 2. Then they say find the area of this region. Or 3 up to 3. 3 up to 3. Find the area of this region. You can just say A equal to, then start here. Only do this one. Only this part. Only this part. So it will be A what? From 0 now up to 3. Then there is 2 here. Then you integrate, let's say it is, maybe it will be y equal to say whatever. If it's 4 here up to 4, then you can see that it will be y equal. Maybe this is how much here is 3. Therefore, this equation will be y equal to x squared. No, it can't be plus. No, I can't think of anything. But if it is like they say what here, say plus 2, then this it will be, is it going to be 2? No, then this it can be 4. Because if it is 4, if x is 4, it will be 8. Oh, but if it is something, then that's right. Then it will be 2. You don't end minus. You start here. It's from 0 up to whatever x here, but don't forget the 2. Otherwise, then you are now going to say A is equal to, then you are now going to include the minus here up to the 3 here, and then this one is going to be, it's not going to be easy. I'm not saying it's going to be, it's still going to be easy, but if you compare the amount of work, this, it will need more work than this one, because this one unit, one limit is 0. Then evaluating where you substitute by 0, when you replace x by 0, you don't even need a calculator. But this one here, you will need a calculator for both limits, the lower limit and the upper limit. If you were to ask me, I will go for this one. Does it make sense? Yes, it does. Must we call it a day? Yes, we can. Call it a week? Yes, we can. A month? No. We still have another meeting scheduled for next Saturday. That one of tomorrow is for the president. Ours is scheduled for next week, Saturday, God willing, same time, same place. This life is God's life. Okay, any question before we call it a day, call it a week? The next topic, it will obviously be what? The next topic. The next topic, it will obviously be the next topic. That is the volume. Or the next unit, that is the volume. Then hopefully you go and revise what? The volume of those standard features. Like what? The volume of a box. The volume of those right cylinders. Then if you understand them, then it will be very simple to understand what? Generally, how do you find the volume of something? Those features which are figures which are not standard. Those figures which are not standard. And that is the next session topic. Anything before we call it a day? You have a question, Matlatsi? You have never said anything, Matlatsi. Surely you are not a robot, Matlatsi, ne? You have never said anything, don't forget. Oh, okay, no, Mataji is not a robot. Pala, any question? Nothing? 3, 2, 1. Bye-bye. Thank you very much. And enjoy your week forward. Thank you very much. Bye-bye. 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 Good. 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 Thank you very much. And see you